Hi guys, this is video number 2 in our L'Hopital's series 8.7 in your textbook. So this example, write this down. We're going to find the limit as x approaches 0 from the right of sine of x over, to the power of x. If I do direct substitution, I'm going to get the sine of 0. Think to yourself, what is the sine of 0? It is 0. And we get this indeterminate form 0 over 0. We cannot apply L'Hopital's rule right now because it's not in the form 0 over 0 or plus or minus infinity over infinity. So we have an exponent. Remember in our last example, how did we get that exponent out of there? Well, we needed to take the natural log, or you could do the log, doesn't matter. But we take the natural log of both sides, and I can bring the exponent down in front when I do that. That's the power rule for logarithms. So bring that x down, and I get ln of I get x times ln of sine of x. Now, if I plug in 0, I get 0, and then ln of 0. That doesn't work. We can't do ln of 0. So now what we need to do is something similar to what we did in the last example. We're going to write this so that so we get this into the form 0 over 0. So we're going to kind of ignore this left side for a while. We're going to find the limit on this side. If you keep writing the ln of y, fine. If you don't, you just need to remember that whatever we get over on the right side, we need to find the answer by the natural log of y equals whatever we get, and then we got to figure out, we got to put it back into exponential form. So similar to what we did in the last problem, we're going to make this multiplying by x. We can also write as 1 divided by x. And then, okay, so if we do direct substitution right now, what we're going to get is, back here when we did the direct substitution, the x, if I put 0 in for x, I get 0, and then this is not actually 0. I think I said 0 before. The sine of 0 is 0, but when you try to take the natural log of 0, remember what the natural log looks like? It's a graph. It's the inverse of e to the x. And as x approaches 0, the y coordinates are approaching negative infinity. So this is actually 0 times negative infinity, which is indeterminate form, but it's not in the form that we can use L'Hopital's rule. So here, if you look at when we rewrite it so that we have the 1 over x in the denominator, instead of multiplying by x, we divide by 1 over x. It's the same thing, but when you do the evaluation now, I have the natural log of sine of 0, which is going to be negative infinity, and then down here, when I have 1 divided by 0, also goes to infinity, and so we end up with negative infinity over positive infinity, which means that now I can apply L'Hopital's rule. All right, so L'Hopital's rule, what we do is we take the derivative of the top, we take the derivative of the bottom. We're not doing the quotient rule, we're not taking the derivative of that entire thing. We're taking, L'Hopital's rule says that if you're finding a limit and you get 0 over 0, or plus or minus infinity over infinity, you take the derivative of the top and you take the derivative of the bottom and then reevaluate the limit. So we have ln of sine of x being the inside function, and the natural log, we're going to go 1 over the inside times the derivative of the inside, which is cosine of x. Think about what cosine of x over sine of x is going to be. And then 1 over x is the same thing as x to the negative first. So when I take its derivative, I get negative x to the negative second. And so cosine, I'm finding the limit of this as x goes to 0 from the right. So cosine over sine, that is cotangent, if you remember. And then this is going to be negative 1 over x squared. And now if I try to find the limit, if I take cosine of 0, that's 1, over sine of 0, which is 0. So this, if you take 1 and divide it by a number that's getting closer and closer to 0, this is going to go to infinity. And down here we're going to have, this is going to negative infinity. We have infinity over negative infinity. So now that means we have indeterminate form, and we're going to apply L'Hopital's rule again. So let's rewrite this. Limit as x approaches 0 from the right. If you, so cosine over sine is cotangent. So I have cotangent of x. And then I have divided by negative 1 over x squared. Well, if I flip and multiply, that's going to be, I can rewrite this as a negative x squared times cotangent of x, or I can, cotangent is the reciprocal of tangent, so I can put this as negative x squared over the tangent of x. Negative x squared over tangent of x. If I put in 0, I'm going to get 0 over 0, which is, again, indeterminate form. I need to take the derivative of the top. I'm going to take the derivative of the bottom. The derivative of the top is negative 2x, and then of the bottom is secant squared x. Putting in the 0 right now, I'm going to get negative 2 times 0, which is going to be 0 in the numerator. And in the denominator, the secant of x, secant of 0, if you're trying to find the secant of 0, it is equal to 1 over the cosine of 0. If you remember what cosine of 0 is, it is 1. So the secant of 0 is 1, and 1 squared is 1. This is no longer indeterminate form. This is actually equal to 0. 0 divided by a number that isn't 0 or infinity is 0. So we're not done, because remember, our left side, back up here, was ln of y. So now I need to find when does ln of y equal 0. And recall that the base of an ln of natural log is e. So to rewrite this, it's e to the 0 equals y. And e to the 0 is 1. So my original problem back here, the limit of this as x approaches 0 is 1. All right, and that is that.